Good morning, dear friends. So today I'm going to discuss with you the geospatial technology applications for disaster management. So I will be specifically talking about the cyclones and tsunami and a bit about the floods, because we have already covered the topic related to the remote sensing and GIS applications in the flood mapping. So when we talk about geospatial technology, let me explain that what do we understand by geospatial technology. Geospatial technology is the integrated use of remote sensing, GIS, GPS and information and communication technology. So you know that we are having the Earth observation devices which are there in the air or in the sky, and we can prepare a number of maps by using the data which is available from aerial photographs or satellite images. And whatever maps we have prepared, those maps are to be integrated as we have learnt in the GIS. So we may be having n number of maps which are to be integrated together, and we have to derive certain action plans. That may be land resources action plan, that may be water resources action plan, there may be utilities plan, right? So for preparing these type of maps, we require the precise locational information, right? So as you know that when we talk about the GPS, global positioning system, it is the position locator. So when we talk about the position, it is nothing but it is the X, Y and Z. So we are talking about the latitude, we are talking about the longitude, and we are talking about the altitude. So up till now, if I talk about the GPS, we are having the Navistar GPS, that is the US controlled. So we are having 24 satellites in 6 different orbital planes. 4 satellites in each orbital plane. So 6 orbits are there in the space and 4 satellites in each orbit, and the height of these satellites is 20,200 kilometers, right? So this arrangement is made in such a way that if you are having a handheld device, right, with that handheld device you are going to any point on the surface of the earth, you are having the reach of at least 4 satellites, so that you can have the exact X, Y and Z coordinates available with you. When we have prepared all these information, we want to share this information, we want to store this information, we want to have the information available for the longer time. So that is where the role of information and communication technology comes. So when the information and communication technology is available with us, we can go for cost effective sharing of the information, cost effective communication of the information. We can prepare one layer at one place, another layer at another place, third layer at third place. So that is the beauty, that we are having the cost effective sharing and management of the information. So when I talk about the geospatial technology, so geospatial technology is also known as Geoinformatics or Geomatics. It is the integration of all these 4 technologies, that is the remote sensing, geographical information system, global positioning system and the information and communication technology. So we will try to understand the role of these technologies for the mapping and management of the disasters. So when we talk about the disasters, as you know that we can categorize these under 3 main heads. One can be the natural disasters, right? So disasters which are occurring because of the natural forces. Technological, there may be some technological failure, and third type of the disaster is the social disaster because of the unrest, right? So when I talk about the natural disasters, these can be geological, for example earthquakes or the landslide. These can be meteorological, for example tornadoes, ice storms or the drought. These can be oceanographic. So oceanographic, we say the hurricanes or the tsunamis, or these can be hydrological. So the example is the floods when we talk about the hydrological, or it can be biological. Biological in the form of the bioarms, bioweapons or the wildfire or the insect infestation. So all these type of the disasters, we say that these are the natural disasters. So when I talk about the technological disaster, for example Chernobyl nuclear disaster was there. So we are having some technology which we are using, say nuclear fusion or fission. We are having, say, radioactive substances using for the energy generation. So if there is failure of that, so that is going to lead to the technological disaster. So these are having the hazardous materials and the processes, so these are dangerous. So there can be, for example, the structure of Fukushima, right? So that is another nuclear disasters. Or there may be the presence of explosives or trains or the aircrafts. There can be the disaster because of these failures, or there may be the failure of the dams, mines, or the power plants. So these we say we categorize these under the technological disaster, that we have used certain technology, we have made something, and there is failure of that. So that is the technological disaster. And then the third disaster is, nowadays you are listening a lot, you are reading a lot, like the social disaster. Social disaster, you see any person on the road, he's like a live bomb, he's like a live moving bomb, because he's having so much tension. You just have to trigger and then it will blast, right? So there may be unrest. There is a lot of unrest in the society, and because of that we are facing these type of the issues. Or there may be some type of the fanatism, right? So that fanatism is leading to a particular type of the mentality or the psychological settings which are becoming a sort of dangerous to the others. For example, terrorism, that may be in the form of the bombings, hostages, or the shootings, or the crowds. We are having the riots or the demonstration. You have seen anywhere throughout the world, right? So these can be the social disasters, right? So just some of the images you see, that on the left hand side top you are seeing the formation of the cyclone. Right hand side you are seeing, on the top you are seeing the landslide or the mass wasting, you are seeing the drought, you are seeing the floods, right? So these can be, just to visualize it, you are having the forest fires, and then again you are having the deep erosion or the formation of the gullies. So when I talk, how the disasters are taking place, as you might be knowing that there is a continuous development. If the development is not sustainable, it is not in tune with the environment, then what is happening? That it is leading to the disasters. So if I talk in general terms, that when I'm talking about the development cannot be stopped, right? Because the societal evolution is there, technological evolution is there, industrialization is there. We are having more and more people on the surface of the earth, and we have to go for the development for the water, health, education, environment, etc., right? So if we are having the development which is in tune with the environment, means we are having the air, land, and sea, we are not spoiling these to a great extent, then only we can think about minimizing the disasters, right? So if we are having the for example, you have seen the Uttarakhand floods, right? So I always say that one of the major reason for these disasters, the loss of the life, is because of the anthropogenic influences. Lot of people, that there is no carrying capacity, there is no land or the space which is available, and you can imagine how many people are visiting there. A religious place has become almost a sort of touristic place, right? So that is where the problem comes. We are having the development, we are not keeping in mind any aspect of, say, river code, building code, or whatever are there. We are not taking those into consideration. So that will always lead to human insecurity, right? Because the development which is not in tune with the environment or sustainability, that is going to lead to the disaster. So there has to be a semblance, there has to be a equilibrium. These are to be in tune. The development is to be in tune with the environment. Then only we can think about minimizing the disasters. So how the geospatial technology can help you in the disaster mitigation? So the basic idea is that we have discussed in the last class about the flooding, right? If we can prepare the flood risk map, right? We are doing a planning that in the future, if there is going to be any disaster, what are the areas where we have to focus first? What are the areas from where we have to evacuate the peoples? What are the nearest areas where we have to take the people? And if I have to develop a particular area, so what are the areas where we are having the minimum risks, so that we can go for any type of the industrial plants or other things? And then this planning is going to mitigate the disasters. You cannot altogether think about removing or doing away completely with that natural disasters. It is not possible, but you can mitigate it, right? So once an event has taken place, then you are learning, right? So again, your learning is helping you in the better planning, right? So we can see that disaster management, all these three components are helping each other. That planning is helping in mitigation, and whereas the experience of the mitigation is giving the learning, which is again helping in better planning, right? So if you talk about today's situation, we are facing with the corona pandemic, right? COVID-19, right? This corona pandemic is unprecedented. The globe has never faced this type of the situation when the entire world is being threatened, right? So any planning which you have done before, that planning is not of that extent, cannot think of those dimensions which we have to apply now. We could not have imagined that we have to go for these type of the lockdowns, right? So I mean, these type of this is a disaster, right? So how we are going to deal with it? You are learning, you are having certain countries who have already faced this situation, and those we are learning from those, that how they have tackled it, how they have moved ahead, and the other countries who are now facing it, and that they are they are implementing that, right? So from the planning you are going for mitigation, and then you are going for the learning. And Government of India and the state governments are doing marvelous job, that looking to the size of the country, we have almost minimized the level of casualties that could otherwise have been, right? So what is the role of ISRO when we are talking about the use of geospatial technology? Well, why I'm using our Indian Space Research Organization? As you all know, that Indian Space Research Organization is the umbrella organization which is coordinating all the activities related to geospatial technology. So what they are doing, for example, in 2018, specifically for the disasters, what they have done, that they have covered about 10 states, prepared 90 maps, and they have used a flood early warning systems in the northeast, and have provided about with 80% success. They have given the early warning in the state of Assam, cyclones, right? So all these eastern coastal areas, right? These eastern states are facing the problem of the cyclones. So 3 states, 3 cyclones predicted, given the warning, and then those are being implemented: landslides, forest fires, and other programs. So this is how the ISRO is coordinating the thing. So what we actually do when we are talking about the disasters, the basic idea is that we are having the Earth observation satellites. From the Earth observation satellites, we are preparing a number of maps, right? All these number of maps, when there is going to be any event in future, then those are being fed to the communication satellite. The information is being fed to the communication satellite, and from the communication satellite we are having the different disaster warning stations or the nodes, right? And the information is being supplied to the local node, and that local node is then coordinating with the district administration and the line agencies, and then they are implementing it for the human, saving the human lives, saving the whatever possible is there. So giving information in advance, asking the people to go to the safe areas. So those type of issues are being taken up. When I talk about in India, so in India we are having the vulnerability which is to different type of the disasters. For example, 57% of the land is vulnerable to earthquakes, right? And of this, 12% is vulnerable to severe earthquakes. About 68% of the land is vulnerable to the drought, 12% of the land is vulnerable to floods, 8% of the land is vulnerable to the cyclones, all these eastern states, right? So you can think about eastern coast states, you can think about that the many parts of the country are prone to one or the other type of the disasters. So this is where we talk about the natural disasters, but you can also think that in addition to it, some cities may be vulnerable to chemical, industrial, or man-made disasters. So this is the situation as of now. So when we talk about the floods, each and every one of us know that we are having the excess of the water in a particular basin, and that water may be spilling from the rivers, or that may be taking the low-lying depressional areas in the other parts because of the spillage, and then that area is being inundated, and we are having the loss to the human life, to the agriculture land, to the property, to the settlements, and so on and so on. So if we talk about the planning, the planning cannot be in piecemeal. It has to be integrated. So there has to be the policies in the planning which are by taking the basin into consideration and going for the integrated approaches. That should be the focus of our plans. So if we just try to see that how the damages are taking place. So if you see that there is approximately 2 billion losses $2 billion losses annually due to the floods. The floods only are contributing to the losses to the tune of 2 billion when we talk about the global figures. And in India, 5 to 6 million hectare of the crop area is affected due to the floods every year. You know that Kosi is known as sort of Bihar, right? Yamuna, we are having the floods in Yamuna. We are having the floods in the Ganges, right? We are having the floods in Ghaggar, right? So we are having the different areas which are being affected, different states which are being affected by different rivers, and total value of the damage to the crops, houses and the utilities is estimated to be about 2,500 crores. Haryana also suffered the floods in 1978, 88, 93, 95, 2010, 2014 and 2019, and each and everyone that 1995 floods, which you had discussed in the previous class, was one of the most severe floods in the history of Haryana. So as I was talking to you, you can see that all these red areas, you are seeing these are the areas where we are having the flooding because of the rivers, because of the excess of the water. Maybe there is a lot of rainfall in the catchment area, or we are having some conditions where the water table is very low, the percolation in the recharge capacity is very less. So even if less amount of downpour is there, that is getting collected on the surface. So we have seen, again we will be talking that when we are talking about Haryana, we say that it is the saucer-shaped physiography. We are having the Shivaliks in the north, we are having Aravali's in the south, we are having dunal areas in the west, we are having Yamuna in the east, right? So we are having a sort of a physiography in which in the central area we are having the poor inland drainage. Poor inland drainage means that we are not having any outlet of the water which is coming over there in the form of the drain, so that even if there is less, I will not say less, but there is more than medium rainfall, it may create flood-like situations. And we have discussed this in the last class, that all the areas you are seeing Ghaggar and you are seeing Yamuna, right? So Ghaggar, we are seeing that there is a lot of spillage of the water, and the excess of the water has come almost up to PHETHAI, right? So this is known as the Rangoi Inundation Canal, right? So we are having like here that the excess of the water is coming almost in the north side of PHETHAI. You will see that there is some areas which are like the depressional areas which are almost flooded whenever flooding is there, right? So all these blackish areas, you are seeing some grayish areas where the water is standing, and the other areas where the water has receded. So we can divide the flood affected water into the inundated areas, from where the water has receded, and the other areas where the water is standing. So the receded areas and the water standing areas, right? So then we can identify how much area is affected and for how much time it is affected when we are having the temporal data, right? So when we talk about the use of this geospatial technology, we can prepare these type of the risk map, which can not only help us in the evacuation, because we know that which are the areas which are under high risk, but also the planning of the district, that if you have to go for some sort of industrial plantation, so it has to be put in the low risk or minimum risk areas. So another very important, which of course I will be discussing today, tsunami. As you know that tsunami is a series of waves called a wave train generated in a body of water by a pulsating or abrupt disturbance that vertically displaces the water column. That we are having some undersea earthquake, right? So because of that undersea earthquake, there is sudden release of the energy, and we can see a sort of a wall is forming, right? Water wall, and that is moving from one area to the another area. So tsunami. Su means harbor, nami means waves. So harbor waves, the literal meaning, it's a Japanese word. So tsunami is the harbor waves. But these harbor waves are really very, very difficult and very, very can be very, very catastrophic, right? So that 2004 earthquake, undersea earthquake, which led to tsunamis on 26th of December. It was, the epicenter was about 150 kilometers west of Sumatra. You can see here, right? We are having Indonesia, we are having India, Bangladesh, Myanmar, Thailand, right? So you can see that wave trains which are moving from one area to other area, right? So when the undersea earthquake occurred, the magnitude was 9 on the Richter scale, and when you see that this is the place where it was, undersea earthquake took place, and then you can see that how the water is moving from here, affecting Sri Lanka, coming to eastern coast of India, and not only the eastern coast, even the western coast of India was also affected by the tsunami. Right, so I will show you some of the images. Like this is the western coast. So in the western coast also you can see that we are having the clear separation with the inland water body in the Arabian Sea, but because of the rise of the seawater, that the Arabian seawater has almost inundated that separation and has moved to the inland water body. And you see that we have discussed in the previous presentation also that this is the one group of Andaman and Nicobar Island, that is a Trinket Island, right? So before the tsunami on 21st, during the tsunami, when 26th the tsunami took place, and then after the tsunami, right? So you can see on 4th of January 2005, right? So we can see the areas in the circle, yellow circles, that in the left hand side we are seeing that as less green vegetation, very good vegetation, but when you're seeing in the right hand side on 4th of January, because of the salt stress and other things, we are having lot of loss to the vegetation. So these type of damage assessment can be made. You see, this is the image provided by GeoEye. It is of Japan, Arahama area of Sendai, Japan, on 10th of April 2010, right? So you are seeing the image on the left hand side. We are seeing the 10th of April, and you are seeing on March 12, 2011. So we are seeing very good, settlement which is present over there, but you see in this image everything has been devastated, right? So this is before satellite image. We are seeing a lot of settlements, very good area development, but here almost everything has been devastated. And you say again another area, we are seeing almost a very good settlement, very good city which is present over there. It is Urias near Miyagi prefecture in Japan again, and you are seeing before the tsunami and after the tsunami, everything almost have been devastated, has been ravaged, has been put to the ground. So again you see that we are seeing in the upper image, not this is before the tsunami, and the right and the below image we are seeing after the tsunami, everything almost has been devastated. Again you see quick word image. So here you are seeing very good settlement and everything has been blown because of the tsunami, right? So what we can do, actually I'm not talking about the tsunami warning system, right? I'm talking about that the damages, how the damages can be assessed, how much area has been damaged because of the tsunami. So as you know, when we are talking about 2004, by that time there was no tsunami warning system in place, and the reason was that we were sure that Indian Ocean is not, it's almost tsunami proof. I mean, we are not expecting any tsunami in this area, but 2004 earthquake that has valued our faith that no, that there can be the tsunami. Then Government of India, they contacted the nearby the neighboring countries, and you will be happy to know that by 9th of March 2005 different countries came together, and in 2007 and 8 India was able to put in place the tsunami warning system. So now we are having the tsunami warning system. If there is going to be tsunami, and the tsunami warning system is doing excellent in India. The next topic which we will be discussing is the cyclones, right? As you know that cyclone, we are talking about the coastal areas, that all these coastal areas are affected by the cyclones, right? So how these cyclones can be monitored and what can be done when we talk about the geospatial technology. So you see this image, we are talking this is the eye of the cyclone. It's a low pressure area, right? This type of the image we have seen in different books, media, right? Just to give a glimpse that how it looks like. And the next slide I will be talking to you about that 1999 earthquake. You see, and then we will discuss. So this is the formation of the cyclone. It has moved after 3 hours, again after 3 hours. So this image is, the presentation is just the animation of the inset images. Every after 3 hours, these images have been taken. You see once more, then we will discuss that we are having the genesis of the cyclone, formation is there, it has moved after 3 hours, again after 3 hours, again after 3 hours it has reached the coast, and then it has moved. So once the formation of the cyclone is there, then you are able to know that yes, the cyclone formation is there, and then you are having the models. Indian Meteorological Department, they are working with different models, and then they are predicting that by this time there is going to be a landfall. Landfall means the cyclone is going to hit the coast, and when it is going to hit the coast, it is going to be associated with lot of rains, right? So what will be the result? The result will be that lot of rainfall will be there, and that rainfall will be inundating the low-lying areas. So what happens actually, if the local administration is able to have the information that the cyclone is going to hit a particular area, after 15 to 18 hours or 24 hours, they will be able to evacuate the people from the low-lying areas to the higher areas. And you can't believe that in 1999, the death toll was more than 25,000. And can you imagine, in 2018 and 19 of the similar magnitude, 2015 also there was a cyclone. So many cyclones have occurred, but because of the prediction by the Indian Meteorological Department, by using different satellite images and acceptance by the people. The important part is that previously, if there used to be advisory, many a times people used to laugh, oh, okay, no problems, that it's not going to happen. But with the passage of time, you have got the reliability that whatever predictions you are doing, whatever forecasting you are doing, that is correct, right? So people have started believing the advisories, right? So they heed to the warning from the district administration, and accordingly they move, right? So now you are able to minimize the casualties, specifically the human life, to a single figure, right? So that is how the geospatial technology is helping, and you can understand that what happens that we are having after the disaster, we are having a lot of damage to the agriculture crops, to the property, to the settlements, to the human life, right? So that is another very, very interesting area where the geospatial technology is of much use. And I will just discuss, I will just share with you the ISRO response. I mean, it's almost real time, right? So near real time information on the inundation due to the cyclone is derived using optical and the microwave, synthetic aperture radar data, and the information is provided to the concerned departments. During 2018, ISRO provided information on the inundation to Odisha, Andhra Pradesh States during the TITLI and PHETHAI cyclones, right? So whenever now the cyclone is there, the cyclone is going to hit a particular coast, particular area, then the ISRO is advising along with the IMD that what is the nature and how much can be the landfall, what can be the wind speed, and all those things. So that's quite interesting by using the geospatial technology. So coming to another, which is of course I will just show you with an example, that we talk about the social disaster. So maybe the terrorist attack, 9/11 terrorist attack, you see that's a beautiful Pentagon building, right? So you are seeing all the 5 sites here. So this is the US Defense Headquarters, right? So if you see the top side, so you are seeing something missing here, right? So this is the place which was hit by the terrorist by using the aircraft, right? So this is a quick bird Econos image, the satellite image, which is having the resolution of 2.5 meters, and you can see that with this satellite image we can have the information about the social disasters as well. And you might be knowing that now India is having the Cartosat 3, and with the help of the Cartosat 3 we are having the spatial resolution of 25 centimeters, means anything which is available on the surface of the earth which is of the size of 25 centimeter by 25 centimeter can be picked up by the satellite, right? So that is where our geospatial technology have moved. So thank you very much, friends. This was all I wanted to share with you related to geospatial technology applications when we are talking about the disaster management. So my basic focus was today that how this geospatial technology is helping us in mapping and management of the damage or the assessment of the damage by using the geospatial technology, maybe because of the tsunami, maybe because of the floods, or maybe because of the cyclones. So thanks a lot for being with me.